Hi, we are here at the CSS Lake, and we're here to determine how healthy it is for living things. So we're going to do a series of tests. Here's the list. We're going to go right down from the top to the bottom. So we're going to start with water temperature with a thermometer. Pretty straightforward. We're going to get that started. Well, let's put the thermometer in the water and let it equilibrate for a few minutes. And at the same time, we're going to do a dissolved oxygen test. Dissolved oxygen. Okay. This test is very simple. I just take a little water, fill it up without splashing too much. It doesn't even matter how much. And then I've got an ampule. And this ampule is filled with a reagent that will react with the water and turn a particular color depending on the oxygen content. Okay, so I just put it in here, snap off the end, and you can see it's pulled in a bunch of liquid. Okay, the water from my sample. I'm gonna invert it a few times, make sure it's mixed. And then we're gonna start a timer for 2 minutes. And we'll run that timer and we'll see what it is at the end of 2 minutes. And we'll compare it to our calorimeter. We'll see how it changes here. Okay, let's go back and check on our thermometer. Okay, can you get in there? So it looks like it's about 9 degrees Celsius, 9 degrees C. Okay, good. Record that. We have about a minute left, so let's talk about something called percent saturation of dissolved oxygen. Water at a particular temperature can hold a maximum amount of dissolved oxygen. The cooler it is, the more it can hold. The percent saturation is a ratio between what it can hold and what it does hold. We're also going to test the oxygen usage over time, over a 5-day spread. This is called the biochemical oxygen demand. And so we're going to take a water sample, make sure there's no air bubbles in it. So we're going to fill it underwater, as so. Cap it. We'll invert it to make sure there's no air bubbles in there, and it looks like we are filled up. And then we are going to cover this with a light-proof material called aluminum foil. And we're going to let it sit for 5 days, during which time anything that goes through aerobic respiration will be using up oxygen out of this water sample. Primarily, that is due to the actions of bacteria. So this is kind of our bacteria test. And we'll sit this for 5 days and then come back and retest the dissolved oxygen and see how much DO it lost. Okay, what's our time like here? Perfect timing. Let's go ahead and compare. So you can tell it's definitely, here's our DO in parts per million. It's definitely bigger than 4 or 5. We'll move it on down. Bigger than 6. Bigger than 8. I'd say it's about a 9, halfway between 8 and 10 parts per million dissolved oxygen. Our next test is nitrate, NO3-, an important plant nutrient. I've collected 15 milliliters of water from our CSS lake. I'm going to add to that some cadmium powder.
And then we'll mix it up for 3 minutes. There we go. And that's going to react with some nitrates. And get them ready for our calorimeter. Okay.
So we are going to mix this for 3 minutes. All right, our 3 minutes is up. We're now going to let this sit undisturbed for 3 minutes. Any of the cadmium particles still suspended will settle to the bottom and will decant off some of the clearer liquid near the surface. The cadmium settled down, so we're going to carefully pick it up. Try not to disturb any of the particles at the bottom. And we're going to decant off some of this into our test sample here without mixing it up too much. All right, that ought to be enough. And then we've got one of those ampules again. We're going to snap that ampule off, mix it, And then it's going to set for 10 minutes. All right, that's our 10 minutes. So our nitrate test is ready to compare to our colorimeter. Similarly to our dissolved oxygen, just slightly different color range. We'll compare. Well, it's bigger than 0. It's got a little bit more orangey color than our colorimeter, but I would say it's probably lighter than 0.7 and maybe around 0.4. I give it about a 0.3. All right, next test is ammonia. NH3 and NH4+, ammonia and ammonium. This can be toxic to fish in high doses. Start by taking 2 milliliters of a water sample. We'll rinse our sample cup first. There we are, 2 milliliters of water. And we're gonna go ahead and put this in here. And to that, we'll add some ammonia reagent. We're gonna start by adding just 1/2 of a milliliter. And then we'll add another 1/2 a milliliter. And we'll put 1/2 of this in here, mix it around. And then we'll come back and add in the second 1/2. And we're supposed to shake it for about 30 seconds. And that's probably close enough. We'll add in the other 1/2. And we'll shake it again. Just for about 10 seconds this time. And then let's see, I believe we let this sit for 5 minutes. All right, we're coming back to our ammonia test. And we are going to compare the color in our jar to the color on the chart. And it looks like it is bigger than 0.25 to me. More like, that looks like a match at 0.5 parts per million or milligrams per liter of ammonia and ammonium.